Hello, Mr. Lee here. All right, numbers 5 and 6, we're still talking about symmetry. The directions are state which type of symmetry the function has. Okay, so this is number 5. We're going to apply each one of these rules. And if the function has these specific types of symmetry, x-axis, y-axis, origin, when we replace the x and y coordinates with x and negative y, or whatever the corresponding match is, the equation will eventually be able to simplify into the same thing, if it's symmetrical. Okay, so I'll show you what I mean. If we're testing for x-axis symmetry, the rule is any xy pair should also have x and negative y pairs. So I'm going to replace the y values with negative y. Okay, so I'm going to change this y into negative y, and then also this y into negative y, right? So instead of x over y equals xy, it's x divided by negative y equals x times negative y. So there are some of these equations that you can simplify now. For example, if we multiply both sides by -1, right? I'll just make that super clear. I'm multiplying by -1 on both sides. We'll clearly see these negatives cancel out, and then these negatives cancel out as well. You're left with the original, right? So because, right, I replaced y with negative y, just like our x-axis symmetry rule states, and then we were able to simplify it back into the original equation, that proves it is it has x-axis symmetry. All right? So now what we have to do is test the other ones. Let's see if it has y-axis symmetry. Instead of replacing the y's stay the same. The x's will now go from positive to negative here, right? So let's see what happens there. So now I'm going to replace the x with a negative x. The y stay the same. So it's going to be like that, right? Same type of deal. If I multiply both sides by -1, let me go on this side, right? Those negatives will cancel out. You're left back with the original. So this function also has y-axis symmetry. Okay? There are functions that could have all three. They could have 2, they could have 1. Okay? So this one has both x-axis and y-axis. Let's test the last one. Origin symmetry. This one's saying that both x and y get replaced with negative x, negative y. Okay, so we'll do one more iteration. Let's see what happens here. X becomes negative x, y becomes negative y, x becomes negative x, y becomes negative y. All right, and this one you don't have to do anything to both sides of the equation because you have 2 negatives already. Those are going to cancel out. You have 2 negatives here already. They're going to cancel out. You're back with the original. Okay, so number 5 has all 3 types of symmetry. Number 6. This is your number 6 function. We're going to do the same tests. Let's start with the x-axis. Y becomes negative y. So that's just going to be this. And there's nothing else we can do to this. So this is already proving that it is not symmetrical over the x-axis. All right, nothing we can simplify to get this back into the original equation. Y is simply changed to negative y. X's don't do anything, so these are clearly not equivalent. Okay, so this does not have x-axis symmetry. Let's test for y-axis symmetry. Your x's will turn to negative x. Your y's stay the same. Okay, so this one is going to be like this. We'll have a negative x here. We'll have a negative x here. And this one will be able to simplify. So if you take a negative number, you raise it to the power of 4, right? You guys can test it with any negative number you like. It's going to turn back positive, right? Whenever you have an even power with these negative numbers, it'll go back to positive. So this will still be equivalent to x to the power of 4. Right? You can simplify it as such. Negative x squared, if you square that, it'll be positive x squared, so that's the same deal, and then plus 2. So this, I was able to get back into its original form. This has y-axis symmetry. Okay, let's test the last one, origin symmetry. So I'm going to replace both x and y now with negative x, negative y. So boom. And then this is kind of the same deal as the last problem, but I'll go through it thoroughly. All right, so this will now simplify to here. All right, and then this kind of is the same result of what we had with the x-axis symmetry. The only thing that changed from beginning to end was the y to negative y. Right side stays the same, so beginning to end, clearly not equivalent. This will not have origin symmetry. Okay, so the only answer for this one was y-axis symmetry for number 6.